Hi, good morning, grade 12 student. Today we are going to start lesson number 6, acid-base titration. We have 4 types of acid-base titration. Strong acid with strong base, first one. Second, strong acid with weak base, weak acid and weak strong base. And fourth one is weak acid and weak base. Now come on, what is titration? Here, in a titration, a solution of accurately known concentration is added gradually to another solution of unknown concentration until the chemical reaction between the two solutions is complete. It means we are going to find out concentration of unknown substance by titrating against a known substance. Here, Ha is acid plus MOH, M for metal, MOH base. When acid and base combine together, they form salt and water. In titration, look here in apparatus, we need a conical flux and a burette, and then we need indicator also. So you are going to find out concentration of acid, so put here in burette, and base in conical flux. If you are going to find out the concentration of base, then put in a burette and add acid in conical flux. And then for both we need indicator. What is indicator? A substance that change color at or near the equivalence point. So what is equivalence point? The point at which the reaction is complete. It means when color change, like you want to slowly add a base to a unknown acids until the indicator change the color. If color change from colorless to pink, from red to yellow, from yellow to red, whenever color change, it means reaction complete, and that time we call that titrations or chemical reaction finish. Now we are going to study individual titration curves, or you can also call pH curves. The first type is strong acid and strong base titration. Both are strong. Strong acid, hydrochloric acid, and strong base, sodium hydroxide, is an example. You have two ways to perform this titration. The first one here, running the acid into alkali. It means you will add acid from burette into alkali in conical flux. So pH change by a small amount until the equivalence point, that is the point where the solution have been mixed in exactly the right proportions according to the equation. It means color change at that point from colorless to pink or any other color. It's depend upon the types of indicator. Look here in this graph, how you will draw the graph. On y-axis pH and on x-axis volume of acid or base. So here we add acid, so volume of acids on pH on y-axis from 0 to 14. 7 equivalence point here. Equivalence point at 7. We will start from 14 to 0. pH from 14 to 0. Basically, these vertical lines from here, this vertical line actually indicate the types of titration. Indicate is it strong acid or strong base, weak acid or weak base. If this vertical line below the 7 and above the 7 have equal part, mean this line equally distributed below the 7 and above the 7, if the size of the line or the portion of the line or the part of the line is equally below the 7 or after the 7, it means both are strong. Second way, running the alkali into acid. So this pH curve we will start from 0 till pH 14. So it's depend how you will get the curve from 14 to 0 or from 0 to 14. It's depend upon that what you are going to perform. Even you are going to adding alkali into acid or acid into alkali. So say similar things at equivalence point, you will get the volume of alkali, then use for calculation, and this is our equivalence point. Look at this vertical lines, this below the 7 and above the 7, the same size of this line, it means both acid and base are strong. Now, this is an example strong acid titration curve in laboratory, how you will perform the experiment, strong acid and base titration curve. Here the volume, you are going to add volume of NaOH and then you are going to find the pH. Look at 7, the volume is 40 and at 7 you will get the equivalence point. Here you can see the color is pink and here methyl orange colors is yellow or light brown. So what is phenolphthalein and methyl red? Actually these two are indicator. As I told you before that when the reaction is complete, the color of solution change. How the color of solution change? By using indicator. So these two are indicators. Later I will explain you what is indicator and what is the suitable indicator for different types of titration. Here we have second type of titration, strong acid and weak base. Strong acid and weak base. Strong acid means hydrochloric acid and weak base is ammonia. Similar way as we did for first, running acid into alkali first. So this pH curve start from 12. It will start from pH 12. Why? Because base is weak. Because base is weak and an acid is strong. So look here at 7, this vertical line you get below the 7, its mean acid is strong. If this vertical line is more part below the 7, its mean it's strong acid. If above the 7 is strong base. And draw this line, this dotted line, red line actually indicate the equivalence point where the reaction is complete or where the color change from any colorless to pink or any other. It's depend upon indicator. The second way, running alkali into acid, we will start from 0. Explanations given here, please read. Now we will start from 0 to 12. 0 to this pH is 12, and again you can see here the vertical lines is this one 7. If you draw from 7, so below the 7 this vertical line part is more, its mean acid is strong. The line from center of this vertical lines, you will get the volume of alkali, then use for calculation. Now, then third type of titration curve is weak acid and strong base. Actually, it's opposite of second. Now, weak acid and strong base. Weak acid, we will take example here ethanoic acid, and strong base is sodium hydroxide. First, acid into alkali, we will start from 14 to down. See here, we will start from 14. Why? Because strong base. Because of strong base, and acids are weak. So you can see this, if you draw line from 7, this vertical line is above 7. If this vertical line is above 7, equivalence point is above 7, it means your base is very strong. Base is very strong. So that's why weak acid and strong base. And second methods, running alkali into acids. So it will start from pH 3 because of weak acid is present. So it will 3 or above 3, it's weak acid. So we will start, initially it's increase rapidly, and this vertical line you will get above 7. Above 7, it's mean your base is very strong. So actually acid and base, strength of acid and base, if you are going to identify from the graph, just focus on the vertical line. Draw the line from 7. If this vertical line below 7 more part, it means strong acid. If vertical line above the 7 is more part, it means strong base. So this for weak acid and strong base. The last types of titration is weak acid and weak base titration. Now both are weak. Both are weak. Examples here: ethanoic acid CH3 COOH and ammonia NH3. Both are weak acid and base. Especially in this case, we will not get a sharp line, vertical lines, because both are weak, so reaction is very fast. We will start, the curve start from pH 12 because the weak base is present. Initially pH falls rapidly, and as you add more acids, the curve becomes less steep because buffer solution will act, and later I will explain you what is buffer solution. See here, we will start from 12. It's very sharp, but you will not get here a vertical lines exactly. So what is the way you can draw the line from 7? Where is the, with 7 line is he cut this curve, then you can find out the volume of acid or base, and this is your equivalence point. If the reason why you will not get these vertical lines, because both are weak acid and base. And the second methods, alkali into acid. See, acid is weak, we will start from 3 or above 3. You will get very sharp line you will get and draw from 7. Then you find out the volume of acid or base from here. When you draw line from 7 and then draw on x-axis, you will get the volume of base and then use for calculation. This is all about how to draw the pH curves between strong acid, strong base, strong acid, weak base, weak acid and strong base, and finally both are weak acid. Now for these types of titration we use indicator. So questions here, how to select indicator. What is indicator? Indicator is a dye. It's a dye, mixture of dyes that change the color over specific pH range. It means the indicator, the change of color depend upon pH range. This is your point. Depend upon pH range. Indicators are considered as a weak acid. The HIN, H for hydrogen, mean acids, IN for indicator. Look at this equation. When unionized indicator color A, then hydrogen ion, and then IN negative mean conjugate base. So what will happen? Adding an acid, the indicator solution shift the position of equilibrium to the left because it's right side. When we increase the amount of hydrogen, it will shift to the left, and when we increase the amount of HIN, it will shift to the right side. So where the equilibrium position shift, this is your first point. That how many types of indicator? These are the many types of indicator you can see in this table. What is the color at low pH and what is the color at high pH, and what is the range of pH. Actually we will depend here the range of pH, and at what time you will get the end point when color change. If you got the pH 3.5, it means that suitable indicator is methyl yellow. So this table is information for you. Come to the next table that I fix for you, that with 4 types of titration, and then we have 4 types of indicator. This is the information you can read, and this I am going to explain, and this is your objective, how to select suitable indicator for suitable titration. These 4 types of titration, and this is the pH range. We will select this pH range from vertical line, from where vertical line will start and what is the ending point of that vertical line, and we can select from indicator. And this table is very important. Please memorize this table, all of you, and these indicators are fixed. Now no need to change. These are fixed indicator for particular types of titration. Thank you very much. Hope you will understand. In next lesson we will start about finding the pKa from titration.